Well, ladies and gentlemen, welcome to projectiles at angles. Up to this point, we've only looked at horizontal projectiles. Now we're going to start looking at launching stuff.
Tough luck for the sheep.
Now when we launch stuff, we need to notice that we are going to launch it at an angle. So as I launch something at an angle, I have two parts to my velocity. I have its horizontal part and I have its vertical part. So this is my overall velocity. This is my horizontal velocity. How are you guys doing? This is my vertical velocity. Now, question is, how do I solve it? Well, this angle up here, theta, is telling me the angle that I launch it at. Theta is just a fancy way of writing angle. This x direction, to solve for the x direction, I just do my overall velocity times the cosine of my angle. And that equals my horizontal velocity. Vertical velocity, I do my overall velocity times sine of my angle. Okay. So let's do this problem. Car is launched at 15 meters per second, is launched at 32 degrees. So I have a launch it at 15 meters per second, and it goes horizontally and vertically in its velocity. And so I do 15 cosine 32, and then I do 15 sine 32 degrees. Okay. When you do it, you should get about 7.95 meters per second, and you should get 12.7 meters per second. A couple things I want you to notice. Do those numbers add up to 15? Good. Hopefully you just said no. But when we are dealing with, these are called vectors or arrows. The easiest way to say it is just an arrow. Is that they add up using a right triangle. And that right triangle, if I do a squared plus b squared c squared, these, if I add them up like a triangle, do add up to 15. They don't add up in terms of just numbers. So I now have my horizontal velocity and I have my vertical velocity. So now we're going to do it just like we did before. So we have horizontal and we have vertical. Horizontal, I have constant motion. Vertically, don't. Here's the thing. Horizontally, I'm going 7.95 meters per second. Now vertically, before we had horizontal projectiles, it was 0. It's no longer 0. I am going up at 12.7 meters per second. Acceleration is negative 10. And that is all I know. Not good, right? But if I split the motion in two, when I'm at the top here, I'm going horizontally. And when I'm traveling horizontally, what is my velocity? I have a horizontal velocity. What's my velocity in the y direction? 0. And so now we're only dealing with half my motion. So I'm dealing with half the time. Now, let's look at the questions that they're going to ask you. First one, what is the car's max height? Second one, what is the car's max distance? But before we do any of these things, we usually need to solve for time, right? Because that's the one thing that travels back and forth. So let's solve for the first one. Let's solve for my max height. Solving for my max height, I've got vf squared for max height equals v initial squared plus 2ad. Final is initial squared plus 2ad. Solve that out and I get 8.1 meters as my max height. This is going too fast, you can always pause it. It's a video. Next up, max distance. Max distance. Which one do I look at? Do I look at vertical or do I look at horizontal? Predict. I'm going to look at my horizontal. So horizontally, I have velocity is displacement over time. I have velocity, 7.95. I want displacement horizontally. What's missing, guys? What do I need? What do I need? What do I need? I need time. How do I solve for time? Well, to solve for time, I'm going to do the easiest one out there. First equation, V final is 0, 12.7 minus 10t, time is 1.27. That's only the time for the first part. So what's the time for my entire part? I multiply it by 2 and I get 2.544 seconds. So I get a horizontal displacement of 20.22. Said 22.